Welcome back, all. Today we're going to go ahead and begin chapter 15, which will deal with files. Now, this chapter is primarily about storing data to a hard drive. So we will talk only about writing the data to the disk. To be able to manipulate files, it is necessary to include the fstream library, the one that you can actually see on my screen here, fstream. So it says include and then fstream. The library has two classes. It has ifstream for reading data from a file and offstream for writing data to a file. Ifstream means input file stream and offstream means output file stream. In this tutorial, we're going to be talking about the later because we're dealing primarily with storing data to a hard drive. Anyway, some general syntax for it would be like this. So we would have, of course, we need to pull it from the std and of stream, and then it's going to be file, and then path to the file. Now this here, it's arbitrary, the file descriptor, so you can basically, it can be f, it can be tra-la-la-la-la, etc. However, the path of the file, you do need to specify to where the file will actually be. Just as with cout, we will perform similar operations with files. For example, to write to a file, you would simply do the following. Well, let's just rename this from tra-la-la to f, to something more sensible. And then to output to a file, you would do basically this, and then something. This something is basically something that will be placed into a file. Okay, so let's go ahead and delete this. This is just the general syntax of things, a pseudocode, if you like, if you will. And let's go ahead and make that a little bit prettier by removing the empty lines and jump into the code. So I have the code written out here. It's not terribly long. There is a lot of repetitive work here, so I figured I wouldn't drag you through rewriting the code twice of something that we've already done. So you remember string from before. We're just declaring a string variable s of type string, and we're prompting the user to enter some text, and then we're going to pick that text up with getLine and place it into the string s. This is very much old news from way before. Now we're gonna enter some number n. We have an int n, and we're just gonna enter it here. And upon doing all of that, we're gonna basically create ourselves a file. So it says std : offstream output file stream. It's going to be f, and if you just do this, if you just type in test.txt, the file will be created in the current project folder, in the current folder of the project. So let me just point that out to you. Files. Okay, so my current, I'm sorry that it says chapter for loops. I didn't rename it. But as you can see here, I have classes basics, files, WinAPI. So this is the current project, files. And if you just go into the folder, you will see pretty much exactly the same thing as me. Depends if you have compiled it before or not. It doesn't really matter. What does matter is that the test.txt does not exist here at all. It is also possible, it will be created, but it is also possible to specify a different path. So, I don't know, you can do this basically. C and then backslash and some folder backslash, and then you're specifying the absolute path where you would like this file to be created on the given system. Okay, so let's just go ahead and delete that because we don't really need the absolute path. We're just going to create it in the current folder. And this is something that has been used extensively in the keylogger, the output to the file, because the keys were being grabbed from the keyboard and then their values were being outputted to a file, and this was then being stored into a particular location on the hard drive. Therefore, the absolute path was actually provided, but this is really arbitrary. This is up to you where you would like to save the file. Now, this action here is going to open up the file, and it's going to open up the file for writing. It doesn't matter whether the file exists or not. If the file does not exist, the file will be created, and therefore you will still be able to write to it. Now, I've just created a simple for loop, which will output the string s n times to the file test.txt. So this is the integer that I'm typing in. I don't know. I first type in some string, and then that string is going to be inserted into this file n times. So I can say insert the same string 10 times, insert the same string 5 times, etc. And then down below, f.close. Once you're done with using the file, you should always, and I mean always, close it. You don't necessarily have to. I mean, you're not going to get an error or anything like that. But trust me on this one, just close it. It's not that difficult. You just need to type in f.close or whatever other name you have used here, and it's going to get closed. This is very important for you. Trust me on that one. Okay, so let's go ahead and run this program. Okay, just one more thing that I didn't mention. I mean, I've included string, but that has been explained previously as well, in case you've missed it. So let's just go ahead and build and run. And there you go, enter some text. Some, blah, 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 blah. Enter. And I would like this string to be inserted into the file, I don't know, 778 times. Completely random number. And that's it. Nothing much has happened on the screen, but if we press enter and exit, you can open up your project folder. And there you go. Sure enough, there is a text document. If you open it, you will see that it was actually inserted 778 times, all the way down to the end. Look at how many of them there are. I could have just as well inserted it 3 times or something like that, but it doesn't really matter. You get the idea. The file was indeed created, even though it was not actually there. Okay, I do believe that we have time to proceed on with the tutorial, because I do have a huge stopwatch to my right that I'm looking at frantically, hoping that I will not break the 20-minute mark, which basically means that I cannot upload the video because there's a time limitation. Anyway, let's go ahead and take a look at some other things as well. So objects of type OFStream here, look, objects of type OFStream have a conversion operator into bool, which indicates if it is in a correct state. So what we can do here, I know it sounds a little bit complicated, but it's not, believe me. It's just to basically verify something. So we can basically write an if statement with this in order to check the state of the object. For example, let me just go ahead and delete this part here completely. Well, I'm gonna delete this part, and I shall delete this part. Let me just make it a little bit better looking. Anyway, so you have this file exists, okay? It exists now, but it didn't exist before we actually created it. However, if I type in this file, I don't know, random file. So this file does not actually exist. Random file does not actually exist in this folder. As you can see, test exists, test was created, but random file does not exist. And if we leave it as it is, it will be created. But I mean, if you output something or do something with it, it doesn't matter if it exists or not, it will be created. But if you would like to check the status, whether it actually exists or not, you would simply type in if, and then you would type in f here, and be like std cout, what shall we write? I don't know. Let's say file does not exist. File does not exist, or you do not have a permission to write to it. So it either doesn't exist or you don't have a permission to actually write to it. This is a bit strange. Give me a sec. You can also do this. So you can put multiple lines like this. So file does not exist or you do not have a permission to write to it. Now, if this returns false, it doesn't mean necessarily that the file doesn't exist. It just means that, hey, the program cannot access it. And for whatever reason, it cannot access it. So it either doesn't exist or you don't have a permission to actually access it. And we can go ahead and build and run. Of course. Build and run. Why didn't it get printed out to the screen? Did it actually create it? It did create it. Well, this part actually created it, so there's no way to actually check it here, but there exists a mode when opening a file. The default is to create or overwrite, which means that if the file does not exist, then try creating it, and therefore it is actually created. And if it does exist, then overwrite it, which means that this will pretty much always return that this case will never happen unless I revoke the permissions. Modes are in basically namespace iOS, which is a sub-namespace of std namespace. Therefore, they are located in it's written out like this, you see? std : iOS, and then you start accessing them. Well, another two semicolons here. So if we want to add at the end of the file and not overwrite the existing file, then we open the file in append mode. So there's some random file here, okay, fine. And if I place a comma and if I type in std : iOS : app means open for appending. Just add to the current content of the file. Do not overwrite the existing content. There are several other modes which we will not use, but let's go ahead and just mention them. You have append, input, output, trunk, binary, etc. You can look these up on the net. There's an entire documentation for the sub-namespace iOS of std. Anyway, let's go ahead and this just wants to append a file for writing. So let's just give it a shot like this. And build and run. Okay, so we have successfully created a third file. So you see, 1, 2, 3. Okay, let me see just if I can switch the permissions around here. Okay, properties, security. How do you change the permission? Change the permissions, click edit. Okay. This guy, deny everything. Okay, let's see if this is gonna work. Apply. Setting deny permissions entry. Deny entries take precedence over allow entry. This means that if a user is a member. Okay, yes. Okay. Okay, swear to God, this is so much simpler in Linux. Let's build and run the program, and there you go. It says file does not exist, or you do not have. Okay, I misspelled this. This should be a space. Or you do not have a permission to write to it. Basically, now we don't have a permission to write to it, and that is a problem. So you do need to. You can't just write to a file, give a command to write to a file, to output to a file, and hope for the best that it's going to succeed. You need to actually verify that you can write to the file before writing to the file. Otherwise, there will be problems. you will have logic errors, and that's going to be a very painful experience to debug and to see what's going on. So the moral of the story is, as I said, you cannot conclude or deduce or assume that you can actually write to a file. You need to verify that you are able to do it before the actual writing process. So if this, okay, if else I don't know, hey there. Okay, so let's go ahead and remove these two. Excellent, so it has went through without any problems. And if I open up random file, just give me a notepad. There we go, it says hey there. But if I do this again, type in hey there 11, if I build and run, okay. Once again, random file, notepad, yes, fine. There we go. It has actually appended it. It didn't actually overwrite anything. It says hey there and then hey there 11. So you're appending what's in the file. If I actually remove this and set it back to the default mode, and if I just type root, okay, that's done. And random file. Okay, there we go. It overrode everything within this. So everything from before is now gone. But always check if you can actually access the file before you actually access it. In conclusion, files are useful because we can use them to store the state of the program or even after it is done executing. Also, some operations we have to perform certain operations using files. For example, storing binary files and sending them via mail. So without permanent storage, your programs are pretty much just confined to RAM and will not be able to leave anything on the hard drive at all. That's why we need files for permanent storage and for accessing hard drive storage, really. Okay, so bid you farewell here, and I hope to see you in the follow-up chapter.